So today we're going to be reviewing linear word problems. All right, so some of them you're just going to have to use your common sense to choose an answer choice, choose a correct equation. Some you have to do a little bit of solving. All right, so either way, any questions you have throughout this, stop me, ask me the question. Don't let me move on if you don't understand it. So here, first of all, I'd like to mention that the format most commonly used and the one that's easiest to understand for us is slope-intercept form, the one you're used to using in this class. Y equals mx plus b. Now, m is what's touching the x or being multiplied by the x. That is your slope. And then b is the y-intercept. Now, over here, we're going to put the words that represent the same thing, but in terms of the word problems. So, first of all, the slope, well, let's start with y-intercept, is the easiest to read. The y-intercept always is the starting point. Any word that means start, initial value, beginning. So whatever it is, that is your starting point. So if I started off with $20 in the bank, then my y-intercept is 20. If I started off at the beginning by paying a $100 fee, my y-intercept is negative 100 because I paid a $100 fee. So it represents the fees. So here are another two words to describe the y-intercept. Start, beginning, or one-time fee. This one's very important. One-time fee. Why is a one-time fee a y-intercept? Because a one-time fee is not going to be multiplied by anything because it's a one-time fee. So that will always be your y-intercept, your constant. Any questions so far? Now, the number that's touching the variable, that means that it's being multiplied to the variable. That is the slope, which we call rate. Slope could be called the rate. It could be called the unit price. But more importantly, anything that's a recurring charge. What does recurring mean? That means it's going to happen monthly, daily, so on and so forth. So the key here to recognizing where there's a slope or where something should be multiplied to a variable are the words that mean multiplication. So here I'm going to write each, per, every. And I'll put some dots because there's a lot of words that mean each, per, every. Now, what's important to you is that all those words mean multiplication. And wherever you read a word that means multiplication, a variable goes there. And now the last one is the y value. The equation, the expression part of the equation is on the right side, 60x plus 20. Solving that is going to give me y. So that tells me that y is always the result. Now, just in case you don't see a y could also be written as f of x or g of x. Anything with a of x next to it, any variable with an f with a parenthesis and an x in the middle, that could be represented by y. It means the same thing. These are the results of an expression that's next to the equal sign. Copy it all down. All right, so now we get to the examples. I'm going to go to the next page. Again, I'm going to do the first example, let you try the second example on your own. Don't do that every time because sometimes I'm going to do the second one, let you try the first one on your own. So just wait for me to tell you which one you're going to do on your own. Either way, when I say do one by your own, select an answer choice, even if you use common sense only to select it. I want you to give yourself a chance at getting something right. You understand? So what's the worst that could happen? You erase the letter B and you put letter A if it's A. So I want you to actually try it. So here on the next page, the first question says, the student council is renting a tent for $350. Now, as a reader, when I'm taking notes, I'm going to circle 350 because that is information that can help us. So this is what I'm going to do when I'm telling you to take notes. I'm going to tell you where to circle, what words to underline, things like that. So here it says the student council is renting a tent for $350 for an upcoming event at the student fair. Each student attending will pay, so each student pays 50 cents. Important information there, so make sure you mark it. Then it says all other attendees pay $2.25 each. Now the next two pieces of information are 200 total students and other attendees we don't know, so they give you a variable, A. Now watch how simple this is. All the information you need is here to select the correct equation. Now, from the beginning, I'm going to show you all of these questions that are multiple choice, you're going to be able to eliminate one or two choices from the beginning. So, over here, does it give you the price per student? Yes, it says each student pays 50 cents. So because there's 200 students, 200 has to be multiplied by what price? 50 cents. So over here on C and D, 200 is being multiplied by $2.25. That's not the price for students. So we know it has to be A or B. Now, pay attention here. If you're trying to calculate the total number of people that are showing up to this thing, are you going to add up the two values or subtract them? Add up because you're trying to find the total. So which is the answer? The one that has the plus sign. We know it can't be A. Yeah, everything represents something that you read. So if you read total, you know it's going to be plus. If you read difference, you know you're going to subtract. Does that make sense? So we eliminated three choices without doing any work, really. So I want you to attempt to do this number 2 on your own. Now pay attention. He wants to increase it by 20%. So that tells you that the number at the end has to be 20% higher than the 15,000. So this number is going to be 18,000. So there's your hint. Go ahead and start it. Select the correct answer from here. This is your first attempt at practicing reading a word problem and choosing an equation that matches what you read. So over here it says, a farmer has a rectangular field that measures 100 feet by 150 feet. The area of something that's 100 by 150 is 15,000. So that is the original area. But it says that he plans to increase the area by 20%. So all you do is multiply 15,000 times 0.20. It gives you 3,000. And you add it to your original value to get 18,000. So because we know it has to be equal to 18,000, we know that we can eliminate answer choice B and we can eliminate answer choice D. Now, over here, this is what tells me which one of these answers is correct. He will do this by increasing the length and width by the same amount. Same amount means that he's going to add the same thing to both measurements. So on A, he added 2x. On the first part, he added 2x. On the second part, he added x. Is that the same thing? No. On C, they added x, they added x. They added the same thing. So that is the answer. Like I said, a lot of common sense on this lesson. Now on this one, I want you to try the first one on your own. I will do the second one on the board after. So this is your OYO question on your own. This one's going to be guided. All right, let's review that first example, and then I guide you through the second one. So up here on the left-hand side, let's read. It says an internet business sells US flags for $16.95 each. Each means multiplication, so we know what goes there, a variable. What's the variable they use for flag? F. So we already know what variable goes there, and we already know what number has a variable attached to it because of one word, each. Now it says plus $2.50 shipping per each flag. But here it goes. They're offering you something. Shipping is free, however, on orders that are more than $100. So the question is important. If they ask, uh, what's the correct equation or inequality for shipping and flags and everything included, that's one answer, which is one of those choices there. But it's not asking about that. It's asking for which correctly shows the number of flags F that must be purchased to get free shipping. So we're only considering the free shipping option here, right? So what happens? What do people avoid? The shipping cost. How do they avoid it? By getting orders that are more than 100. So now we should know what goes in here. If you're avoiding shipping, are you going to pay 250? No, because you're going to get orders that are more than 100, so you're not going to pay the 250. So that tells me D cannot be the answer because it has the 250 in there, and C cannot be the answer because the 250 is there also. It's added to the 16 bucks. So if you're getting free shipping, why would they charge you the 250? That's not what you said, right? So now, the only two choices are these two choices. Does this say orders that are equal to 100? No, that says orders that are more than 100. Which one of these represent more than or greater than 100? B. Simple? Now look over here. Justin plans to spend 20 bucks. Can he spend more than 20 bucks? Can he spend more than 20? No. Can he spend 20 exactly? Yes. Can he spend less than 20? Of course, you can only spend up to what you have, right? So we already know that it has to be greater than or equal to, well, less than or equal to 20 because he can't spend more. So less than or equal to 20. So already, which choices can I eliminate? C and D, because those say greater than or equal to 20. That, by the way, here's a hint. How this faces the variable tells you less than or greater than. If it's close to where the variables are, it's less than. If it's open to where the variables are, it's greater than. Now, from those two choices left, the only difference is that the 350 has an F on it on answer choice A, and the 350 has an R on it on answer choice B. So we just have to read this and see which one is actually placed next to the correct variable. So here we go. $3.50 for a regular pack. That means 350 is going to have the R on it. So the answer choice has to be B. It is easy. When it's a word problem, like I said, it gets easier because they give you so much information that you can use your brain to figure it out instead of math. So it's not a lot to copy down. Just circle the words that I circled, scratch out the answer choices I scratched out, and more importantly, understand what I'm trying to deliver here, okay? All right, on this next example, again, I'm going to let you do the first one on your own because it's a little bit easier. The second one is a three-parter. I want to do that one with you. I want to guide you through that one so you can, again, see how easy it is. So go ahead and do the first one here. All right, so here it says, in 1997, there were 31 laptops, right? Either way, when I start reading and I see an equation, I usually stop reading because the equation tells me that the starting point is 31. It's there, right? It also tells me how much it's increasing each whatever that is, years, months, whatever. So as we read, we're going to find out that it's years they're talking about. So let's continue. 1997, there were 31 laptops. Starting in 1998, they bought 20 more laptops at the end of each year. Each means multiplication. Whenever you read a multiplication word, what belongs there? A variable. So in this case, they tell you what variable to use. X is the years after 1997. Up there it said 1998. That's not the numbers you're using. X represents years after 1997. So now, what was the total number of laptop computers at the end of 2005? So how do you know how many years you're going to plug in for X? By subtracting from 1997 to 2005, which gives you 8 years. Now that I know the number I'm going to plug in, where am I going to plug in 8 years? For X, because X represents years. So all we have here is T equals 20 times 8 plus 31. That gives you 160 plus 31, which is 191. Any questions on that one? Now, pay close attention to the next one here because it's a multi-part question. Make it a little bigger for you guys. All right, so pay attention here. First thing you read is that Ian borrowed $1,000. I'm going to stop right there because if you borrow money, what's going to happen? Each month you're going to do what? Make payments to that balance. So when you make payments to a balance that you owe, is that number going to get bigger or smaller? Smaller. So let's create an expression for Ian right now. He borrowed 1,000 and it's going to get smaller. At what rate is it going to get smaller? He tells you right here at $60 per month. So 60M. There's your expression for Ian. Focus. Pay attention. So 1,000 minus $60 a month. That's Ian's expression. Now let's create another one, but for Ken. Ken borrowed 600 bucks. So it's 600 minus, now he's going to pay how much per month? He's going to pay $20 a month. Now that we have both expressions for both people, we can get to the questions and answer the questions they're asking. So pay attention to the question here. Write an equation that can be used to determine after how many months the boys will owe the same amount. Answer this question for me. Same means what in math? Equals. So that means I'm going to get both expressions and make them equal to each other. So 1,000 minus 60M equals 600 minus 20M. There's my answer for part A. The two expressions we came up with, and the equal sign because it says same amount. This word, by the way, this phrase, same amount, shows up a lot on any standardized test because you need to know that equals means same amount. So whenever you see same amount, you're just going to make both expressions equal to each other. Now, what happens after you create an equation? They're going to make you solve that equation. And that's exactly what they're asking on part B. Determine algebraically, which means solve, really, simplify, and state in how many months the boys will have the same amount. So now, we grab that equation, which was our answer for part A, we solve it, and we get the answer for part B. So let me remind you how to solve these things. You get the variables to the same side first. I recommend you use move the smaller variable. Which one's smaller? Negative 60 or negative 20? Negative 60 is a smaller number because it's a big old negative. So we're going to add 60M to both sides. That leaves us with 1,000 equals 600 plus 40M. Two more steps. Subtract the term that's on the same side as the variable and then divide by the coefficient. So we're subtracting 600 from both sides. We get 40m equals 400. And now we divide both sides by the coefficient, which is 40. 400 divided by 40 equals 10. So the answer is 10 months. Any questions so far? Now, part C says, Ian claims that he will have his loan paid off. Now be careful when you read this. He'll have it paid off 6 months after they owe the same amount. So we already calculated same amount. Same amount was in how many years? Oh, how many months? 10 months, right? So if they're saying 6 months after 10 months, what's the value that you actually need to plug in for X? 6 months after 10 months would be what number? Common sense, guys, come on. 6 after 10 equals how much? 16. After, right? So after they owe the same amount was in 10 years. After that is 6 more. How many years passed? 16. So my value that I'm going to plug in to see if he's right or not is 16. So let's plug it in. 1,000 minus 60 times 16. Why am I using that one? Because it says Ian claims it. So we use the Ian expression. Now that gives you 1,000 minus 960, which leaves a balance of $40. Did he pay off his balance? No, he didn't get to pay off his balance. He still owes 40 bucks. So the answer is no, he still owes 40. Does that make sense? That's enough explanation for me. Because I know it says explain your reasoning. That's enough explanation for me, this work. Any questions? All right, let's move on to the next page. Now, on this one, I'm going to do the first one. You do the second one on your own. So pay attention to the first explanation. On the first example, it says, you talk, oh, dropped it. You talk on the phone, Y minutes on a day. So we know Y represents minutes. Here it says on day X of every month. So we know X represents the day of the month. And now the equation that represents that is Y equals 2X plus 1. Now, here, the person is not the one claiming something. The cell phone company is claiming something. So the cell phone company claims that you talked 12 minutes on the 4th day. And the simple question is, are they right? Are they correct? So watch how easy this is. X represents the day of the month. So 4th day would be a 4 for X. 2 times 4 plus 1, which gives you 8 plus 1, Y equals 9. Now, Y is minutes. So that means that on the 4th day, 9 minutes. So the answer is no, you're wrong. Now, how wrong are they? You have to pick the answer that says the correct information, the information that we got when we solved the 4th day. So, you know the answer is no, so we could eliminate A. Now, which one has the correct amount of minutes? C. 9 minutes on the 4th day. Now, go ahead and try the second one on your own over here. Make sure you look at that first page that I wrote some notes for you. That first page is going to tell you, remind you what makes 40 the constant and what makes 90 the slope or the rate. Okay, let's review it. So up here it says a satellite television company charges a one-time fee and a monthly service charge. Now, we talked about this on the first page. A one-time fee, an installation fee, is a constant, a number that's not getting multiplied by something because it's not a recurring charge. So that one-time installation fee has to be the 40. And then the monthly charge has to be the number with the variable attached to it because the variable is going to represent the amount of months, the number of months. So here you have the slope, 90x. So first of all, we can eliminate answer choice A and answer choice D. Why? Because 90 is not your installation fee. The installation fee has to be the constant, which is 40. So between these two, the only difference is one says Y is the total cost and X is the months. The other one says X is the total cost and Y is the months. Now, what do I always tell you in word problems X represents? Time. So make sure you pick the one that says X is months because X is time. That make sense? Also, cost is always a result, and result is always y. Correct, correct. If that would have said z equals, then z is the result. You're right. If you just read it, you can understand that. All right, on the next page, try the first one on your own. We'll do the second one. So let's review that first question. So here it says one-time fee is 50 bucks. One-time fee is the number with no variable on it, and the number with no variable on it is your y-intercept. The question is, what does 50 represent? All you have to do is select the one that best explains what the 50 represents. Now look at the second example. This is a great one because these questions take up like half a page and people skip them thinking they're difficult. Super simple, especially when you get a graph with dots on it. There's so much information for you on a graph with dots on it. So let's read here. The graph shows the relationship between the number of cookies a presenter gives at a convention. No, wait, let me read that again. The relationship between the number of cookies a presenter at a convention had left to give away. So think about the situation here. Somebody's presenting. After each presentation, she gives away cookies, right? So what happens to those cookies? Are those cookies going to increase or decrease? Decrease because she's giving cookies away, right? So for example, the y-intercept is 180. What would that represent? The starting point of the cookies, the amount of cookies, right? That would be the y-intercept. But look at the question down here. The question says, what does the x-intercept represent? So first thing we want to do is circle that value that they're pointing us at. What is the x-intercept here? What number? 6 is the x-intercept. Now, does 6 represent cookies or presentations? Presentations. Very good. Now, do me a favor and tell me how many cookies she's got left at that 6 presentations. None. Because here she has 180. It's going all the way down to 0. You with me? So now, simple. You look at the answer choices, pick the answer choice that says 6 presentations, no cookies left. Now, obviously, don't pick it right now because I want to go through each answer to show you why it's not correct. Okay? The number of cookies, we're looking at 6. Okay? The number of cookies the presenter had, I stop right there. 6 is not cookies, 6 is presentations. So once you see the number of cookies, can't be the answer. They're talking about the wrong column. Now, B says the maximum number of cookies. Again, we scratch it out. Why? Because they said cookies, and we know 6 is not cookies, 6 is presentations. Now, answer choice C says the number of presentations the presenter made per hour. First of all, this says hour. Do you see hour in any of these two categories? So the time doesn't matter, right? What matters is presentation being done, how many cookies I give. The time doesn't matter. She could take 10 hours for one presentation. She's still going to give you 20 cookies. You understand? So, simple one to eliminate. And obviously, our answer is D. Let's read it. The maximum number of presentations before running out of cookies. That tells me 6 presentations, no cookies. So, the answer is D. So far, I haven't had any questions. Please ask questions if you have them, unless this is so simple that we all get it, which would be amazing. All right, let's move on. This is the last page. These are the last two examples. So this is what I'm going to do. I'm going to do the first one, let you do the second one because the second one is a multi-parter. Okay? So on the first one, it's tricky, so be careful. All right? These words are a little bit tricky, but I'm going to teach you a way to avoid the trickiness. So here it says the development budget C for a computer game company is described by the equation C equals 50,000 T plus 10,000. And T is the number of years since the company's creation. Now they're asking which is true. So all these statements kind of look alike, right? Look at A and look at C. A says each year development expenses increase by 50,000. C says each year development expenses are 50,000. They're very similar, right? So for you to determine which ones are correct, you'd have to be very good at deciphering the English language in these word problems, right? But I'm going to show you a trick that'll avoid having to remember these things. So pay attention here. We have an equation, right? What can we do with an equation? Plug in a value, right? Now, what value can I plug in? Any value I want. Now, why would I plug in a 200 when I can plug in what number? A 1 or a 2, right? So watch how simple this is. Grab the equation. 50,000 times 1 plus 10,000. And let's get a value for it. So 50,000 times 1 is 50,000. 50,000 plus 10,000, 60,000. You see what I did there? I just plugged in a 1. Now, for me to see which one of these is correct, I got to do this again. But instead of 50,000 times 1, I'm going to put 50,000 times what? 2. Very good. Now, 50,000 times 2 is 100,000. 100,000 plus 10,000 is 110,000. Now, how much did it increase? From 60,000 to 110,000, how much did it increase? By 50,000. If I plug in a 3, what do you think the next answer is going to be? 160,000, because you know it increases 50,000 every time. You with me? Now we know which one is the answer. A has to be the answer because it says increase by 50,000. Does that make sense? Of course. But for example, me, that I'm very good at deciphering these words, I looked at A and C and had to think about it for 2 minutes to myself. Because, what makes C incorrect? rather than A incorrect, right? I was actually leaning towards C for a couple seconds there. So if this is all I'm saying, if you get to a point where you're in between two answers, what can you always do to check it out? Plug in a 1 and a 2, right? And it works every time. Even if they're talking about thousands, you plug in a 1, you plug in a 2, you're going to see what the change is. Now, on this next one, I want you to do it on your own, but notice these numbers. Where are you going to get these numbers from? I'm going to show you. Total expenses. What are you going to do to the expenses? Add them. Here it says total income. What are you going to do to the income? Add them. When you do that, this should give you 2,000. This should give you 7,000. Round it off. Those are the numbers in here, obviously. So all you have to do is plug in one of these things here and here and here, and two symbols, math symbols, in the smaller ones. And then the second part is just answering the question, and they give you a value. So go ahead and try it on your own before I explain it to you. That will be the last example we go through before your work. All right, let's review this question. If you're not sure, please ask me. So here, because it says, let's read the whole thing just in case. A new bakery opened and has tracked its expenses and income for the first month. So expenses on one column, income on the other. This data is summarized by the table. If the bakery predicts that future months will have similar expenses and income, write an equation that could be used to determine how many months it will take for the bakery to have 20,000 more, or to have a total income that's 20,000 more than its total expenses. That is what's going to give you your equation down here. So pay attention to the words that I'm going to change into math symbols right now. What I just underlined says, how many months will it take to have a total income? What is a total income? 7,000 M. Income, when you add it up, it rounds off to 7,000. This one rounds off to 2,000. So what they're saying is total that the total income is. What does is mean in math? Equals. So 7,000, or the income is 20,000 more than the expenses. That's what's missing here. 20,000 more than the expenses. So that should be 20,000. More than means plus, and expenses is 2,000 M. Now, if you switched it around, it's still correct. If you put 2,000 M here plus 20,000, it is the same thing. So I'll take both answers. Now, that's the answer for the first one, the equation you got to come up with, right? So notice, not everything gets used in the box. It's only the information that was calculated. Now, on the bottom, how long does it take for the income to be 20,000 more than its expenses? That's exactly the equation we created, so we just have to solve it. So when you're solving this equation, the first thing you have to do is get the variables to the same side, because how can you get a variable by itself if it's on different sides? You can't. So we need to subtract 2,000 M from both sides. That leaves us with 5,000 M equals 20,000. And now you divide both sides by the coefficient, which is 5,000. And 20,000 divided by 5,000 equals 4. So in 4 months, the income will be 20,000 more than its expenses. Any questions? All right, so you got 15 minutes or so left of class. Use it for whatever you want that's related to this class. And then tomorrow you will do the worksheet. The worksheet is 15 questions long. Most of them are multiple choice like this. Maybe a few of them are like these. So either way, you have examples to look at while you're doing the work, and you have me here tomorrow to ask questions if you get stuck.